Hello everyone, I'm Atusa Jawahari, a first-year PhD student from the Department of Industrial Manufacturing and Systems Engineering. Today I would like to present my work evaluating the root causes of parking citations, a UTA case study. First, let me introduce my research motivation. We all know about the frustration of finding parking in the busy cities and areas. It's a big problem and made worse by more cars and not enough parking spaces. But there is a solution. Smart parking systems is a kind of solution. These systems use real-time data to make parking much more easier, especially in populated areas like university campuses. Now, I want to talk about the research gap my study aims to address. Although these systems have a lot of benefits, there is an evident research gap in understanding their effect on people behavior. To address this gap, the objective of this study is to develop a long short-term memory LSTM model. This model will help us to predict and analyze parking citation following the launch of SPS in the UTA campus. The research flow is showed in Figure 1. We use the parking violation data for the past 5 years, and then we try to clean the data set and remove the irrelevant parking citations. Then we focused on selecting the right features to capture parking patterns during academic and non-academic periods. The LSTM model, an ideal model for time series data, was trained. We validated and tested the model to ensure its accuracy. And finally, we employed the statistical test to validate the model prediction against the real-world data. Let's discuss our methodology. Our model implemented with cross and have specific hyperparameters for optimal performance. We utilize the Adam optimizer with a learning rate of the 0.001 hyperbolic tangent activation function in the LSTM cells and a linear function in the dense layer. To handle the input data, we employed a window size of 5 for parsing sequences. This model consists of a single LSTM layer followed by a dense layer, and we split the dataset into the two subsets, training and validation, with 18% for training and 20% for validation. We evaluate the performance of the LSTM model using the mean square error, MSE, and R-squared. For the model development, 4 features have been used: semester break, exam periods, holiday, and weekend. Now I want to discuss the dataset we utilized for this study. The data was provided by the UTA Parking and Transportation Services. We focused on 6 types of violation related to the incorrect parking. Our dataset spans 1,945 days, covering from August 2018 to November 2023. And the data before the launch of SPS in September 2023 is used to train and validate the LSTM model. In Figure 3, you can see a comparative analysis of average parking ticket issuance across this time frame from 2018 to 2023. The analysis highlights how parking compliance fluctuates based on the academic calendar, like the exam period or semester break, and the weekly cycles, like the weekday, weekend, and holidays. Moving to our results section, in Figure 4, we visualize the results of our ticket prediction and the actual tickets during the test interval. Based on the Figure 4A and 4B, the model predicted more tickets than were issued. This suggests that the Parking Finder application has a noticeable effect on reducing parking non-compliance. We also compared the frequency distribution of weekly tickets as shown in figure 5. This histogram showed the actual tickets were generally lower than the prediction, and this reinforces the conclusion that the parking finder application positively influenced parking behavior. To statistically validate the difference observed between the actual and the predicted distribution, we employed a Kolmogorov-Smirnov test. The test yielded a large test statistic and a small p-value. Indicates that the actual and the predicted tickets issuance data originate from the different distributions. In conclusion, our results shows that the actual parking tickets were lower than the predicted numbers following the launch of the Parking Finder application in the UTA campus. This deviation suggests the effectiveness of this application in reducing the issued tickets. These are my references, and thanks to my professors for their valuable insights, and thanks to Innovation Day for this opportunity.